Hello everyone, our topic for today is about introduction to problem solving. Word problems. In every area of mathematics, you will encounter word problems. Some students are very good at solving word problems while others are not. When teaching word problems, I often hear I don't know where to begin or I have never been able to solve word problems. A great deal has been written about solving word problems. A Hungarian mathematician, George Polya, did much in the area of problem solving. His book, entitled How to Solve It, has been translated into at least 17 languages, and it explains the basic steps of problem solving. These steps are explained next. According to Polya, step number 1 is understand the problem. First, read the problem carefully several times. Underline or write down any information given in the problem. Next, decide what you are being asked to find. This step is called the goal. Step number 2 is select a plan to solve the problem. There are many ways to solve word problems. You may be able to use one of the basic operations such as addition, subtraction, multiplication, or division. You may be able to use an equation or a formula. You may even be able to solve a given problem by trial and error. This step will be called strategy. Third step is carry out the plan. Perform the operation, solve the equation, etc., and get the solution. If one strategy doesn't work, try another one. This step will be called implementation. The fourth one is evaluate the answer. This means to check your answer if possible. Another way to evaluate your answer is to see if it is reasonable. A dimensional check will do. Finally, you can use estimation as a way to check your answer. This step will be called evaluation. When you think about the four steps, they apply to many situations that you may encounter in life. For example, suppose that you play basketball. The goal is to get the basket into the hoop. The strategy is to select a way to make a basket. You can use any one of several methods such as jump shot, a layup, a one-handed push shot, or a slam dunk. The strategy that you use will depend on the situation. After you decide on the type of shot to try, you implement the shot. Finally, you evaluate the action. Did you make it? Good for you. Did you miss it? What went wrong? Can you improve on the next shot? Algebraic representation. When you solve an algebra word problem, you must first be able to translate the condition of the problem into an equation involving algebraic expression. An algebraic expression will consist of variables or letter-like numbers, operation signs such as addition, subtraction, division, and multiplication, and grouping symbols such as parentheses, to name a few. Here are some common phrases that are used in algebra word problems. Addition can be denoted by the sum, added to, increased by, larger than, more than. Subtraction can be denoted by the words less than, subtracted from, decreased by, exceeds, shorter than, difference between. Multiplication can be denoted by the product times, multiplied by, twice as large, three times a number, one half of a number. For division, we have divided by and quotient of. For the equality sign, It can be denoted by the words is, will be, is equal to, and seldom we use the word gives. Here are some examples of word statements translated into symbols. The first column is the word statement, and on the right column is the symbolic representation using variables and numbers. 5 times a number is translated in mathematical symbols such as 5x. 3 more than a number is 3 plus x. A number decreased by 7 is x minus 7. 1/2 of a number is 1/2 x or x over 2. The square of a number, translated as x squared. 4 times a number minus 8 is 4x minus 8. The cost of rope at 15 cents a foot is 0.15x. 9 added to twice a number is 9 plus 2x. Here are examples of word statement translated into symbols where the word statement is a complete sentence. 5 times a number is 30. The mathematical sentence, which is, in this case, a mathematical equation, is 5x is equal to 30. When an English statement is a complete sentence, it can be translated into a mathematical equation. So, say for example, 3 more than a number will be 23. So 3 plus x is equal to 23. A number decreased by 7 gives negative 16. So x minus 7 is equal to negative 16. 1/2 of a number is 13. There are two ways to write. 1/2 x is equal to 13 or x over 2 is equal to 13. The square of a number added by itself is 12. So in mathematical sentence, we have x squared plus x is equal to 12. 4 times a number minus 8 gives 24. 4x minus 8 into 24 into mathematical symbol. The cost of rope at 15 cents a foot is 90. So 0.15x is equal to 90. 9 added to twice a number is 35. So that becomes 9 plus 2x is equal to 35. Let's try to solve number problems. One number is 8 more than another number, and the sum of two numbers is 26. Find the numbers. Let's represent the rectangle, the blue rectangle, to be the number. The second number will be 8 more than it. So that means this green rectangle is 8 units long. The sum of two numbers is 26. So the blue rectangle plus the blue rectangle plus the green rectangle must sum up to 26. The equation we have is x plus 8 is equal to 26. 2x is equal to 26 minus 8 gives us 2x is equal to 18. X is equal to 9. Hence, the two numbers are 9 and 17. Next example. Find three consecutive integers whose sum is 63. Let us represent the first integer to be the vertical blue rectangle. The integer after that will be one more than the blue rectangle and 2 more than the first integer, and its sum is equal to 63. The working equation will be x plus 1 plus x plus 2 is equal to 63. Then 3x plus 3 is equal to 63. 3x is equal to 63 minus 3. 3x is equal to 60, dividing both sides by 3 gives x is equal to 20. Therefore, the three consecutive integers are 20, 21, and 22. Another example. If the sum of two consecutive even integers is 42, find the numbers. Let us try to denote the blue rectangle as the first even integer. Since even integers differ by 2, then the next integer will be the first integer plus 2. And its sum is equal to 42. The working equation will be x plus 2 is equal to 42. 2x plus 2 is 42. 2x is 42 minus 2. 2x is 40. X is equal to 20. The two consecutive even integers are 20 and 22. Now let's try digit problems. In solving digit problems, we have to consider the place values of each digit. In the number 275, 2 is on the hundreds place, 7 is on the tens place, and 5 is on the ones place. The digit sums is equal to 2 plus 5 plus 7 is 14, but its value is determined by 2 multiplied by the place value plus 7 times 10 plus 1 is equal to 275. Let's try the first problem. The sum of the digits of a two-digit number is 15. If the digits are reversed, the new number is 9 more than the original number. Find the two-digit number. Okay, let us use the table for the original and reversed digit. We have tens place and ones place. On the tens place, let us put x. And on the ones place, since the sum of the two-digit number is 15, we subtract x plus 15 to represent the other digit. Then its value is x multiplied by 10 added by the quantity 15 minus x. The reversed order will be 15 minus x on the tens place and x on the ones place. The value of the reversed digit is 10 multiplied by 15 minus x plus x. The working equation will be, from the problem, we have the condition, the new number is 9 more than the original. Hence, the new number 15 minus x multiplied by 10 added by x times 1 is equal to 9 plus the original, which is 10x, plus the quantity 15 minus x. Simplifying, 150 minus 10x plus x is equal to 9 plus 10x plus 15 minus x. Collecting similar terms, negative 9x plus 150 is equal to 9x plus 24. Negative 9x minus 9x is equal to 24 minus 150. Combine similar terms, negative 18x is equal to negative 126. Dividing both sides by negative 18 gives x is equal to 7. Therefore, the two-digit number is 78. Next problem. In a three-digit number, the ones digit is 3 more than the hundreds digit, and the tens digit is 1 more than the hundreds digit. If the sum of three digits is 10, find the number. In the table below, we represent x to be the digit on the hundreds place, x plus 1 is the digit on the tens place, and x plus 3 is the digit on the ones place. Since the sum of all the digits is equal to 10, we have x plus 1 plus x plus 3 is equal to 10. Combining similar terms, 3x plus 4 is equal to 10. 3x is equal to 10 minus 4x. That gives us 3x is equal to 6 and x is 2. Hence, the three-digit number is 235. Let's proceed with solving age problem. A mother is 10 times as old as her daughter. In 24 years, she will be twice as old as her daughter. Find their present ages. To solve this type of problem, we rep, we use the table indicating the person, the timeline for their ages, say past, the present, and the future. So in this case, we don't need to use the column for the past ages, and we only have the present and the future ages of the two person, the mother and her daughter. In the problem, it states that the mother is 10 times as old as her daughter. So let us represent the age of a daughter to be x and her mother to be 10x, 10 times as old. In 24 years, meaning their present ages added by 24. So therefore, in 24 years, the daughter will be x plus 24 years old, while her mother is 10x plus 24. Another condition in the problem is that the mother will be twice as old as her daughter. So the equation coming from the problem is 10x plus 24. The mother's age is equal to 2 times the age of her daughter, x plus 24. By distributive property, we have 2x plus 48. The left member is 10x plus 24. The left-hand side is 10x minus 2x, transferring 2x on the left-hand side, and positive 24 on the right-hand side will become negative 24. Solving for x, we get 8x is equal to 24. Dividing both sides by 8, we have x is equal to 3. And so the mother is 30 years old while her daughter is 3 years old. Next example. Bill is 8 years older than his brother. In 3 years, Bill will be twice as old as his brother. Find their present ages. Again, in this problem, we don't have information for their past ages, only the present and the future ages of two involved persons, Bill and his brother. In the first condition in the problem is that Bill is 8 years older than his brother. So let's represent the brother's age to be x, and Bill will be 8 more than the age of his brother, represented by 8 plus x. In 3 years, meaning their present age added by 3. So in 3 years, Bill's brother will be x plus 3, and Bill is x plus 3 plus 8, or 8 plus x plus 3. The equation derived from the problem is Bill is twice as old as his brother. 8 plus x plus 3, the age of Bill, is twice as old as his brother, 2x plus 3. By simplifying, the left-hand side become x plus 11 is equal to 2x plus 6. Collecting similar terms, x minus 2x is equal to 6 minus 11. Negative x is equal to negative 5. Multiplying both sides by negative 1, it will become x is equal to 5. So Bill is 13 years old while his brother is 5 years old. Next problem. John is 6 years older than Mary. If the sum of their ages is 32, find each one's age. The person involved are John and Mary. Their present age is, let's say, Mary is X years old, John is 6 years older than Mary, so X plus 6. The sum of their ages is 32. Then, the equation derived, x plus 6 plus x is equal to 32. 2x plus 6 is equal to 32. 2x is equal to 26. X is equal to 13. Hence, John is 19 years old while Mary is 13 years old. The next type of problem is solving distance problem. In distance problem, we have to remember that the rate multiplied by the time is equal to the distance traveled. Say for example, a person walked from his home to the football stadium at a rate of 3 miles per hour. After the game, he rode the bus back the same way at a rate of 22 miles per hour. If the total time he spent traveling was 2 hours, how far did he walk? Okay. From his house to stadium, the rate of travel time is 3 miles per hour. And the time spent traveling is 2 hours minus x because we represented x to be the time spent traveling from stadium to the house. With a total of 2 hours, that will be 2 minus x spent from house to stadium. The distance traveled from his house to the stadium is the product of the rate and time consumed. Therefore, 3 multiplied by 2 minus x. And from the stadium to the house, the rate is 22 miles per hour multiplied by the time x, that will be 22x. Since the distance from his house to the stadium is the same from the stadium to the house, we will get the equation 3 multiplied by 2 minus x is equal to 22x. Simplifying, 6x minus 3x is equal to 22x. 6 is equal to 25x. 6 over 25 is equal to x, or x is equal to 0.24 hours. Since we are asked to find how far did he walk, we use this value to compute the distance. So the distance is equal to rate multiplied by the time. So the distance is equal to 3 multiplied by 2 minus 0.24 gives us 5.28 miles. Therefore, the person walked for 5.28 miles, which is also the distance from his house to the stadium. Next problem. A freight train leaves Pittsburgh traveling east at 15 miles per hour. 4 hours later, an Amtrak train leaves Pittsburgh traveling east at 35 miles per hour. How many miles from Pittsburgh will the Amtrak overtake the freight train? The table shows the rate time and the corresponding distance the freight train and the Amtrak train traveled. The freight train is traveling 15 miles per hour. The Amtrak train is traveling 35 miles per hour. Let X denote the time spent by the Amtrak train. The freight train has a time of X plus 4 since the freight train is already ahead of the journey 4 hours ago. Its distance traveled 15 multiplied by X plus 4 and the Amtrak train is 35 multiplied by X. The equation is 15 times X plus 4 is equal to 35. This will be the time that the Amtrak train starts to overtake the freight train. Simplifying, 15x plus 60 is equal to 35. 15x minus 35x is equal to negative 60. Negative 20 is equal to negative 60. Dividing both sides by negative 20 gives us x is equal to 3 hours. So the distance traveled is equal to the rate multiplied by the time. So 3 multiplied by the rate 35, that will be 105 miles. Therefore, the Amtrak train will overtake the freight train 105 miles from Pittsburgh. Two automobiles are leaving from the same point and are traveling in opposite directions. One is going 10 miles per hour faster than the other is. After traveling 2 hours, they are 160 miles apart. How fast is each automobile traveling? The table shows the rate, time, and corresponding distance of two automobiles traveling in opposite direction. Let us denote x to be the rate of car A. X plus 10 is the rate of car B. The time spent by the two automobiles is the same, which is 2 hours. The distance covered by car A is 2x. The distance covered by car B is 2 multiplied by x plus 10. The total distance covered by the two automobiles is equal to 160 miles. The equation 2x plus 2 multiplied by x plus 10 is equal to 160. So 2x plus 2x plus 20 is 160. 4x is equal to 160 minus 20. 4x is 140. We'll get x is equal to 35. So the car A is traveling at 35 miles per hour and car B is traveling at 45 miles per hour. Mixture problems. Imagine mixing two different liquids with different concentration. We will obtain the third mixture, which is a combination of these two. And remember that the amount of pure is equal to the product of the amount times the percentage. So we have to set up the table for mixture 1, mixture 2, and the obtained mixture 3 such that the amount, percent, and the amount of pure are given in columns. For example, a pharmacist has two bottles of alcohol. One bottle contains a 10% solution of alcohol and the other bottle contains a 5% solution of alcohol. How much of each should be mixed to get 20 ounces of a solution, which is 8% alcohol? The first bottle contains 10% solution, added to the second bottle, which has 5% solution, and obtained the third mixture, which is 8% alcohol. So the table shows for a mixture of 10%, we denote the an amount x. Since we need 20 ounces, the 5% solution should have 20 minus x as an amount. So the percent given, that's 10% for 10% solution and 0.05 for 5% solution. The amount of pure is obtained by multiplying amount and its percent. So here we have 0.10x, 0.05 times 20 minus x, 0.08 times 20. 0.10x plus 0.05 times 20 minus x is equal to 0.08 times 20. Because when we add the amount of pure from the 10% solution added with the amount of pure in the 5% solution is equal to the amount of pure in the 8% solution. 10x plus 5 multiplied by 20 minus x is equal to 8 times 20 by multiplying the first equation with 100 to get rid of the decimal. Then we have 10x plus 5 plus 100 minus 5x is equal to 160. 5x plus 100 is equal to 160. 5x is equal to 160 minus 100. 5x is equal to 60. We get x is equal to 12. Therefore, the pharmacist must mix 12 ounces of a 10% solution with 8 ounces of 5% solution. Second problem. A craftsperson has two alloys of silver. The first one is 70% pure silver and the second one is 50% silver. How many ounces of each must be mixed to have 12 ounces of an alloy which is 65% silver? Okay, for the table, we have the mixture, amount, percent, and the amount of pure. For 70% pure mixture, we denote it with an amount x. And for the 50% pure, we denote it with 12 minus x. Alright? And then the total amount of pure for each solution is obtained by multiplying the amount with its percentage. So therefore, for 70% pure, we have 0.70x. 50% pure, 0.5 times 12 minus x, with a total of 0.65 times 12. The equation gives us 0.7x plus 0.50 multiplied by 12 minus x is equal to 0.65 times 12. Okay, multiplying the first equation with 100, we have 70x plus 50 times 12 minus x is equal to 65 times 12. We have by distributive property, 70x plus 600 minus 50x is equal to 780. Solving for x, we have 20x is equal to 780 minus 600. 20x is equal to 180. Dividing both sides by 20, we have x is equal to 9. So the craft person must mix 9 ounces of 70% silver with 3 ounces of 50% silver. Another type is mixing coffee that costs different amount. Say for example, a merchant mixes some coffee costing 40 pesos a pound with some coffee costing 30 pesos a pound. How much of each must be used in order to make 20 pounds of mixture costing 37.50 per pound? Set up the table for the mixture of 40 peso coffee, 30 peso coffee, and the resulting mixture will be a 37.50 coffee. So let X denote the amount of a 40 peso coffee mixed with 20 minus X of 30 peso coffee. So the cost for is of course 40 and 30 respectively. So the value will be the product of the amount and cost. X multiplied by 40 is 40x. 20 minus x multiplied by 30 is 30 times 20 minus x. And the total value for the mixture will be 20 pounds multiplied by 37.50. Okay? We have now the equation 40x added by 30 multiplied by 20 minus x is equal to 37.5 multiplied by 20. Okay? So 40x plus 600 minus 30x is equal to 720. Solving for x, we have 10x is equal to 720 minus 600. 10x is 120 and x is equal to 12. Therefore, the merchant must mix 12 pounds of 40 peso coffee with 8 pounds of 30 peso coffee. Next, we have solving finance problem or investment problem. A person has 5,000 to invest and decides to invest part of it at 4% and the rest of it at 6.5%. If the total interest for the year from the amounts is 245, how much does the person have invested at each rate? We have to set up the table for the first column, investment, principal, rate, and then the interest. We use time is equal to 1 because the duration of the investment is 1 year. For investment A, we denote it with the variable X. And since 5,000 is the total amount to be invested, and a portion of it was already invested at A, then for investment B, we will only have 5,000 minus X as a principal. Now, for investment A, it has a rate of 4%. In investment B, we have 6.5%. And in decimal, we have 0.065 as its value. Now, the total interest earned from the two investment is equal to 245, meaning we need to add the interest earned from investment A with the interest earned from investment B to get 245. So, 0.04x added by 0.65 multiplied by 5,000 minus x is equal to 245. We multiplied the whole equation with 1,000 to clear the decimal here. So we have 40x added by 65 multiplied by 5,000 minus x is equal to 245,000. Then distribute, we will get 40x plus 325,000 minus 65x is equal to 245,000. Then solve for x, negative 25x is equal to negative 80,000 and x is equal to 3,200. Meaning, the person must invest 3,200 at 4% and 1,800 at 6.5% to earn a total interest of 245. Another problem, a person has twice as much money invested at 6% as he has at 3%. If the total annual interest from the investments is 315, how much does he have invested at each rate? Again, we set up the table for principal, rate, and time is equal to the interest earned. From investment A, we denote it with the variable x. Investment B is 2x since it is stated in the problem that the person have invested twice as much money at 6% as compared with 3%. Therefore, the interest earned from investment A is obtained by multiplying the principal and the rate, so 0.03x, while the interest earned from investment B is 0.06 multiplied by 2x, with a total of 315. The equation is given by this 0.03x added by 0.06 times 2x is equal to 315. Multiply the whole equation by 100 to get 3x plus 6 multiplied by 2x is equal to 31,500. 3x plus 12x is equal to 31,500. 15x is equal to 315,000. X is equal to 2,100. Therefore, the person must invest 1,200 at 3% and double the amount, which is 2,400 at 6% to earn a total interest of 350. An investor has 3 times as much money invested at 5% as he has invested at 2%, and 600 pesos more invested at 3% than he has invested at 2%. If the total interest from the 3 investment is 98, find the amounts he has invested at each rate. Since the interest earned from the 3 investments A, B, and C has a total of 98, we obtain the equation 0.05 multiplied by 3x plus 0.02 multiplied by x plus 0.03 multiplied by x plus 600 is equal to 98. Multiplying this with 100, we will get 5 times 3x plus 2x plus 3 multiplied by x plus 600 is equal to 9,800. Simplifying to get 15x plus 2x plus 3 multiplied by x plus 600 is equal to 9,800. And that is further simplified to 20x equal to 8,000, giving us x is 400. Thus, the person must invest 400 at 2% and 1,200 at 5% and 1,000 at 3% to earn a total interest of 98 pesos. Let's proceed with lever problems. A lever is governed by the law that W sub 1 or weight sub 1 times distance sub 1 is equal to weight sub 2 times distance sub 2. Imagine a 100 kilogram weight on the left side is being balanced by another weight on the right side. As the weight goes further back, it becomes lighter. But if it is closer to the fulcrum, the weight is much heavier than the weight on the left side. It is only equal to the weight on the other side if its distance are the same. Let's proceed with an example. Bill weighs 120 pounds and sits on a seesaw 3 feet from the fulcrum. Where must Mary, who weighs 96 pounds, sit to balance it? Imagine Bill weighing 120 pounds on one end. He is 3 feet from the fulcrum, and Mary, on the other end, is 96 pounds. Where must Mary sit? So by principle, W sub 1 times D sub 1 must equal to W sub 2, D sub 2. So Bill is 3 feet from the fulcrum and weighs 120 pounds. So 120 multiplied by 3 is equal to 96 multiplied by x. 360 is equal to 96x. Dividing both sides by 96, we get x is equal to 3.75. Therefore, Mary must sit 3.75 feet from the fulcrum. In the second example, the fulcrum of a lever is 3 feet from the end of a 10-foot lever. On the short end rests an 84-pound weight. How much weight must be placed on the other end to balance the lever? By principle, W sub 1 times D sub 1 is equal to W sub 2 D sub 2. 84 multiplied by 3 is equal to x multiplied by 7, where x is the weight to be put on the other end. 252 is equal to 7x. Dividing both sides by 7, we get x is equal to 36 pounds. Therefore, a 36-pound weight must be put on the other end to balance the fulcrum. The third example involves two persons on one end and two persons on the other end. On a 16-foot seesaw, Fred, weighing 80 pounds, sits on one end. Next to Fred sits Bill, weighing 84 pounds. Bill is 4 feet from the fulcrum. On the other side, at the end sits Pete, weighing 95 pounds. Where should Sam, weighing 75 pounds, sit in order to balance the seesaw? Okay. The equation W sub 1 D sub 1 plus W sub 2 D sub 2 is equal to W sub 3 D sub 3 plus W sub 4 D sub 4. 80 multiplied by 8 added by 84 multiplied by 4 must equal to 75 multiplied by x plus 95 multiplied by 8, where x is the distance of Sam from the fulcrum. Okay, simplify. We have 976 is equal to 75x plus 760. 976 is minus 760 equals 75x. 216 is equal to 75x. X is equal to 2.88. Therefore, Sam must sit 2.88 feet from the fulcrum. Another type of problem is work problems. The basic principle is that the amount of work done by one person, machine, or pipe plus the amount of work done by the second person, machine, or pipe is equal to the total amount of work done in a given specific time. Also, the amount of work done by a single person, machine, or pipe is equal to the rate times the time. That is, rate multiplied by time is equal to the amount of work done. The total amount of work done is always equal to 1 since the task is 100% completed. In solving work problem, we have to set up the table for the R times time is equal to the amount of work done by worker A, B, and its total amount of work done is 1. Say for example, Frank can cut a lawn in 2 hours. His brother Jeff can cut the same lawn in 3 hours. How long will it take them if they cut the lawn at the same time? So the table for Jeff and Frank, the rate of Frank is 1/2, while the rate of Jeff is 1/3. Why is the rate of Frank 1/2? Since Frank can cut the lawn in 2 hours, Then the amount of work done for 1 hour by Frank is 1/2. If Jeff can finish the loan in 3 hours, so in 1 hour, he can only finish 1/3 of the job. So we have to denote X to be the time that Jeff and Frank works together. So the amount of work done for Frank is X over 2, while the amount of work done by Jeff is X over 3. The equation X over 2 plus X over 3 is equal to 1, since the task will be 100 completed after that. Multiply the whole equation by the GCD to get 3x plus 2x is equal to 6. Then 5x is equal to 6. X is equal to 6 over 5 or 1.2 hours. 1.2 hours in converted into minutes is equal to 72 minutes. Therefore, we have 1 hour and 12 minutes. So, Frank and Jeff can cut the lawn in 1 hour and 12 minutes working together. In the next problem, one pipe can fill a large tank in 5 hours and a bigger pipe can fill the same tank in 3 hours. How long will it take both pipes to fill the tank if they are turned on at the same time? Pipe A has a rate of 1/5 because it will take 5 hours to fill the tank. Pipe B has a rate of 1/3 because it can fill the same tank in 3 hours. The time for the two pipes working together will be denoted as X. The amount of work done for each is X over 5 and X over 3. The equation X over 5 plus X over 3 is equal to 1. Multiplying the whole equation with the GCD, we will get 3x plus 5x is equal to 15. Then 8x is equal to 15. Dividing both sides by by 8, we have 1.875 hours. Converting that into minutes, we will have 112.5 minutes or 1 hour, 52 minutes, and 30 seconds. So the tank can be filled in 1 hour, 52 minutes, and 30 seconds when both pipes are turned on. A person can clean a small office building in 8 hours, and her assistant can clean the same building in 2 hours. If on a certain day, the assistant shows up 2 hours late and starts to work, how long will it take both people to clean the building? Okay, the boss can clean the small office building in 8 hours, so her rate is 1/8. The assistant can clean the office building for 12 hours, so the rate is 1/12. The time is X for the boss and her assistant is X minus 2 because her assistant shows up 2 hours late. The amount of work done, multiplying 1/8 and X to get X over 8, 1/12 times X minus 2 is X minus 2 all over 12. The equation X over 8 plus X minus 2 all over 12 is equal to 1. Getting the LCD and multiplying the whole equation by it, you will have 3x plus 2x minus 4 is equal to 24. Then 5x is equal to 28. X is equal to 5.6 hours or 336 minutes. Converted into hours and minutes, we have 5 hours and 36 minutes. Thus, it will take 5 hours and 36 minutes for both people to clean the building. That will be all for today. I hope you learned something from the video, and next time we will be discussing non-routine problems. Thank you. Have a good day.